All right, so today we will start calculus, okay, in Spech. So this lesson, I kind of want to combine something you're probably it's gonna take you like 2 weeks in methods to learn. So hopefully I can finish in this lesson. Okay. So that's why it's a summary. It's sort of like summary video. Okay. So in terms of differentiation, the only thing we learn in methods is differentiating polynomial. Okay. But we can also differentiate other things using different derivative rule. So I'm gonna give you a summary table here. So can you guys please take out your book and take notes? Some of you might be familiar with this already. Like Kazu, I'm pretty sure you're familiar with this. And maybe these two girls. All right, so we learned how to differentiate polynomial, right? So we basically put the power in the front and then the power reduced by 1. Okay, however, when it comes to exponential, logarithm, like circular function, we got different derivative rules. So let's start with exponential, ex. So for ex, the derivative, so this is fx and this is x dash. All right, so ex, the derivative would be very, very easy, ex itself. All right, and then log ex. Yeah, very good. Ooh, okay, sine x, cos x, okay? Cosine x, negative sine x, okay? Tangent x, secant square. All right, so these five derivative rule are something you need to copy down. How do we prove them? We basically use first principle to prove them. But today I'm not going to show you. In method class, if I have time, I will show you guys. Because today I'm going to talk about these 5 and the 3 rules in one lesson. So I will just tell you the summary here. I will put this here, and later when we apply the question, you can just directly use the table. Okay. Then now let's talk about the second thing, which is 3 rules. So basically in differentiation, no matter in methods or Spech, we only have 3 different rules. They are chain rule, product rule, and quotient rule. Okay, so what does it mean by chain rule? Let me give you an example. Let's say fx equal to x squared minus 2 to the power squared. Well, in this case, in year 11, what we can do is that we can write this as x squared minus 2 times x squared minus 3, and then you expand it, and you differentiate each term, right? But from now on, we don't have to, because if it's like, this is not 2, if this is 12, it's very difficult for you to use binomial theorem to expand it. So we have chain rule to do it, okay? So chain rule basically means it's sort of something like this. This is like a train, right? So basically you have an inner function and you have an outer function. Does it make sense? An inner function and outer function. So how we're going to do it is that we simply differentiate. For example, this one, we simply differentiate the outer function. The outer function would be the bracket to the power of 12. Yeah? So we just go 12 x squared minus 2, and this become 11. And now we finish differentiate the outer function. And then we times the derivative of the inner function. The inner function is inside the bracket. Make sense? So therefore, it's times 2x. Yeah? So that would be 24x times bracket x squared minus 2 to the power of 11. So that's the derivative. Does that make sense? And if I want to find this derivative at a specific point, I simply substitute x equal to something in here, and then you can find out the gradient. Yes? Yeah.
Why is it?
Why is what?
Why is it 12? Why are you finding 12?
This one, because this is 12.
Oh.
Yeah, 12 you put there.
And then you minus 1.
Yeah.
To the power of 12, not to the power of 2.
Yeah, because I changed it. The beginning I said 2, but then if it gets complicated, you can't just expand it, right?
Yeah.
All right, so basically that's the chain rule. Okay, so now let's try to use this thing to do a chain rule questions. So let's try.
Mr. Wang told us different methods. We didn't change rules in methods.
Okay. Actually, it's the same rule. It's the same thing, but you are using the formula, right? You're using the formula. However, for you guys, if you want to achieve like more than 37 in methods, you can't actually rely too much on the formula. Okay? If you just want 30, that's okay, you look at the formula. But for you guys, if you want 37 up, don't look at the formula, just directly do it, because when you do application questions, you can't just look at the formula and do things like that. Especially if you want to do conceptual thinking, you need to understand why this is the case instead of using the formula. Okay? All right. So basically it's dv du times du dx, something like that. That's the formula. All right, so let's try gx equal to e to the power of 5x plus 1. So let's try to find this derivative. For this one, right? For example, this one.
Yeah.
When we take this as one guy, the outer function means this is one guy.
Yeah.
So 12 you put 12 there, you just copy this down.
Yeah.
So outer function is the whole thing, you just copy it down. Yeah.
Wait, no, so the derivative is e to the power of 5x plus 1
And then times derivative of inner function.
times the derivative of the inner function, which is
The inner function is this guy,
oh,
right?
is that 5x
Yeah.
plus 1. Okay.
All right, so let's talk about this. So g dash s. So first of all, we're gonna differentiate the outer function. The outer function is this guy, right? This is the outer function. And if you look at here, so it would be itself, right? So the outer function, we think this is one guy, just like here, we think this is one guy as a whole. So e to the power of 5x plus 1. And then after we differentiating the outer function, we need to differentiate the inner function, which is 5x plus 1. What's the derivative of 5x plus 1? 5. So you times 5. You simplify. So that's the derivative. So p
That's the highest one.
p equal to
Log p or something.
which one you
I
want?
don't know, so I want to practice that one.
10.
I like that.
All right, let's differentiate this guy. We differentiate it. So which one is the outer function? The whole thing, right? And the inner function? 3x plus 1. So you differentiate the whole thing based on?
So it's m squared
3x squared, 3x plus 1.
Very good. You can, I like the way that you think you can jump this. It's basically 3 second square 3x plus 1. There you go. Product rules. What does it mean by product?
You
Multiply, right? You have two terms or even more terms. So let's say 3x squared plus 1 times, give me any, what do you like?
2x squared plus
2x squared plus 2? Okay, let's make it cube, okay? All right, so if I want to differentiate this one, okay, you also have formula in methods, all right? You also have formula for product rule, but I will tell you how we do it without formula. Basically, we just differentiate the first one, all right? Differentiate the first one, that would be 6x, right? Times original of second one plus the other way around. So which is original of first one times the derivative of second one. And that's all. Okay? You don't have to simplify for now, but when it comes to simplifying, it's much, much more difficult. Why we need to simplify? If I want you to make it as a factorized form, it's for you to solve stationary point. When you make it to equal to 0, you need to get the factorized form so that you can make this guy equal to 0 or this guy equal to 0, right? But we're not doing that now, so we just do, yes.
Spares is going straight into my bank account. That's what's
Fur. The evidence of you committing a crime has been recorded. Alright, so that's the product rule, okay? If you can't remember that, instead of memorizing the formula, you can just go D-O-O-D, dude. Derivative, original derivative. It's much easier than formula. Dude. And also, by the way, if you look at the formula, it actually go O-D-D-O. But you know it's the same, right? Because this way, you just swap them the same. But why do I do D-O-O-D instead of O-D-D-O? It's because I want to show you the connection between product rule and quotient rule. Because quotient rule is actually you differentiate the first one first. Okay, I will show you later. So that's the product rule. Let's have a go. Jx equal to, what do you like?
Try sine.
Sine x times some. Now, let me try this one. X squared times log ex. It would be a very nice one. Sure. Alright, so let's do it. J dash will equal to derivative of the first one, which is 2x times original plus x squared times derivative of this guy is 1 over x, and then you can simplify. You can't simplify for the first term, but you can simplify for the second term. That's all. Yep, that's the product rule. Does it make sense?
Yeah.
Alright, last one, quotient rule. Can I write this out? Can I write this out?
Working out part.
Alright, then let's do it here. I will use the same term here. We got two terms. 3x squared plus 1 over 2x cubed plus 2.
Yeah.
So this is the quotient rule, right? What does it mean by quotient? Divide. If you see division, you use quotient rule. There's only two things that are different from product rule. If you remember the product rule, it's pretty easy for you to do the quotient rule. It's only two different things, two differences. We also differentiate the first term, like there. So that would be 6x times the original of the second one. Product rule is plus. Quotient rule, therefore, is minus. So that's the first difference, okay? And then we do the same thing the other way around. Original of the first one times derivative of the second one. Okay, we finished the first step, and so far we only have one difference, right? And the second difference is, Emily, the second difference is, you know, it would be this one square, the bottom square. You divide it by the bottom square. So two differences. This one and this one are different to the product rule, and that's the quotient rule. Okay, that's the quotient rule. Okay, so if I want to differentiate this one, everyone knows it's a product rule, right? It's a product rule. So let's do the product rule first. So product rule is I differentiate the first term, which is 2 times the original second one, right? So let me make it this way because it would be easy for us to further differentiate. And plus the original of the first one, right? And then differentiate the second one. But you have to notice the second one is actually a chain rule. We differentiate this one, it would be half 3x minus 5 to the power of negative 2, and then times 3. You guys get this bit?
Yeah.
So this is the derivative of this one, right? Original times the derivative. Alright, so a lot of you might stay here, but if I want you to go further to simplify it, to make it as a factorized form. What does it mean by factorized form? Something times something.
Yeah.
In the bracket, right?
Yeah.
How can we simplify this? I want to get rid of I don't want plus. Yeah, I want to get bracket times bracket, that kind of form. How can we simplify?
Well, we can cancel the rest.
We can take out the common factor,
Yeah,
right?
that's fine.
Take out the common factor. So let's simplify this first. So this would be 2 over 3. Alright, so what is the, we have two terms here. What is the common factor for these two terms? This one is not common factor. Not common factor, but for this and this, do they have common factor here? The base is the same, but the power is different.
You put the base down.
Yeah, so basically if I write in this form, you guys probably know a to the power 3 plus a to the power 5. Do we have common factor? A3, right? The lower power one.
Yeah.
And then 1 plus a2. Make sense?
Yeah.
So same here, if I want to do the common factor here, I basically take out the lower power. Yeah? So that would be 3x minus 5 to the power of negative half.
Yeah.
That's the common factor. And then the first term, what is left? Of course, the 2 is left, right?
Yep.
How about this guy? That's the tricky bit. What is left? If I take out this as the common factor, what is left here?
You get. Well, okay, so you divide by that number.
Yeah, the power would be,
1. No, 3x plus 5.
is it 1? It is 1. Because if you think, right? So a to the power of half. Now you take out the common factor, which is negative half. You basically ask yourself, what is this guy?
Yeah.
So negative half plus 1, because the base is the index law, right? You plus the power, it will equal to half. So this is 1, which means it's nothing here. Yeah? Alright, and then plus this one. That would be 3x plus 2 over 3. And that's all. So now we factorize it. Does it make sense?
Where did the 2x plus 1 go?
2x.
Yeah. Oh, yeah.
But you can copy it down and then expand later.
Yeah.
Yep. So that's everything. Alright, that's everything. Why do we need to get the factorized form? Is because we learned stationary point, right? Stationary point is to make the derivative equal to 0. If I make this guy equal to 0, you can't solve for x. But if I make this guy equal to 0, you basically just made this guy equal to 0. It's a linear, right? It's a linear, as you can see. So pretty easy to solve. It's like a year 7 questions. And for here, because you know you have the negative power, so it must be something like this. And you know the bottom can't be 0, which means this guy can never ever be 0. So the x would, you basically solve this equation and you solve for x. And you can find the x value for the coordinate.